Reports say OpenAI's first consumer device may not be a phone, tablet, or pair of glasses. It may be a small computer for the home with no screen at all, designed to listen, observe, and decide when it should speak. That description comes from reporting based on people familiar with the project. OpenAI has not officially announced the product, its final design, or its launch date, so every specific feature should be treated as provisional. The larger story is less speculative. OpenAI bought Johnny Ive's device company IO in 2025, creating a hardware effort built around the idea that artificial intelligence needs a new physical form. The reported first form is a portable, screen-free speaker with a camera and other sensors. It would combine familiar smart home functions with ChatGPT-style conversation and a deeper model of what is happening around it. That sounds like a smarter version of today's voice assistants, but the ambition is different. Traditional speakers mostly wait for a command. An AI agent can interpret language, images, memory, and context, then choose among many possible actions. OpenAI's current voice systems already support natural conversation, interruptions, images, and, on eligible devices, live camera input. A dedicated object could make those interactions persistent and hands-free instead of something you deliberately open on a phone. A screenless computer removes friction. You do not unlock it, search for an app, or stare at a menu. You speak, point, move through the room, and expect the system to understand what matters. That could be genuinely useful for cooking, accessibility, reminders, translation, home control, and communication. The best version would feel less like operating software and more like asking a capable assistant for help. But convenience depends on perception. To help without constant commands, the system needs signals, microphones, cameras, motion sensors, device activity, location, and a history of earlier interactions. The device would not need to record everything continuously to create privacy concerns. Even selective sensing can reveal routines, relationships, health clues, arguments, visitors, and the shape of daily life. OpenAI says current voice and video clips are retained with chat history for defined periods and provides controls around deletion and training use. A dedicated home device would need equally clear controls that work without a screen. A glowing light is not enough if people cannot tell what the system is sensing, why it activated, where information is processed, or how to erase it. Trust requires understandable behavior, not just a policy page. The absence of a screen makes this harder. Screens can display permissions, transcripts, settings, and warnings. A screenless product must replace those functions with voice, lights, physical controls, or a companion device. Bystanders create another problem. The owner may have accepted the terms. A guest, cleaner, tradesperson, or neighbor speaking through an open window may not know that an AI system is interpreting the room. That is not a new issue. Phones, doorbells, and smart speakers already create similar tensions, but a more perceptive and proactive device could make the boundary less obvious and the collected context more valuable. Memory is central to the appeal. OpenAI describes memory as a way for ChatGPT to retain preferences, projects, and constraints across conversations. In a home device, that could turn scattered interactions into a long-term model of the household. That model could make the assistant more helpful. It could remember how a household communicates, which routines matter, and what information each person prefers. It could also become difficult to audit when its understanding is wrong. A mistaken calendar entry is annoying. A mistaken belief about who is home, who is authorized, or what someone intended could affect locks, messages, purchases, or private information. The safest architecture may split work between the device and the cloud. Simple wake detection and sensitive processing can happen locally, while larger models handle complex reasoning remotely. That can reduce delay and exposure, but it raises cost and engineering demands. A portable device adds another layer. It may move between rooms or travel with its owner, carrying context across spaces where different expectations and rules apply. Reporting also suggests the product may have mechanical movement intended to make it feel more expressive. That could improve attention and communication, or make an always-present machine feel uncomfortably alive. Design matters because people respond socially to objects that look, move, and speak as though they are attentive. A device does not need a human face to encourage attachment or authority. That can be useful when technology needs to communicate urgency or confirmation. It can also make users overestimate understanding, competence, and loyalty, especially when the system speaks confidently. OpenAI warns that voice systems can make mistakes. In a screenless environment, errors may be harder to notice because there is no persistent text to inspect before acting. Good design would slow the system down for consequential actions. Purchases, door access, private messages, and account changes should require clear confirmation, identity checks, and a visible record somewhere the user can review. The product also enters a crowded market. Amazon, Google and Apple already sell speakers, displays, and home platforms. OpenAI's advantage would have to come from intelligence and interaction, not simply another box with microphones. Hardware is unforgiving. It must survive drops, heat, dust, unreliable networks, and years of software updates. It also has to be affordable enough that people will place it in their homes. A cloud service can improve every week. A physical product creates inventory, warranty claims, repairs, batteries, supply chains, and electronic waste. Success depends on operations as much as model quality. The reported partnership with Johnny Ive's team signals that OpenAI understands this. The device must make sensing, privacy and personality legible through form, materials, movement and sound. The strongest version of this product would not demand constant attention. It would remain quiet, make uncertainty obvious, ask before acting and give every person nearby a simple way to understand or disable it. The weakest version would chase engagement, interrupt frequently, hide its data flows and encourage emotional dependence. Screenless computing can remove friction for the user, or remove the moments when the user would have reconsidered. Regulators will eventually ask familiar questions: when is the device listening, what is stored, can guests opt out, and who is responsible when an autonomous action causes harm? Those questions matter before launch, not after millions of homes have adapted around the product. Ambient systems are difficult to remove socially because routines, memories, and connected devices begin to depend on them. For now, the crucial fact is that the reported product is still under development. Its final capabilities, privacy model, price and release timing may change, or the project may be delayed. But the direction is visible. AI companies want to move from software you open to systems that accompany you, perceive your surroundings and remember enough context to act. A computer without a screen could make technology feel more natural and accessible. It could also make the computer harder to see, question and switch off. The real test will not be whether it can talk, but whether people can remain in control.